Friends, today we are going to start the unit 2 of the paper 1 of the physics, that is the lenses. That already you have seen about this part in the 12th. Lens, before starting we will see the introduction. We all of know that when the refraction of the light takes place at an interface between the two transparent media, we get the following relation for the relative refractive index mu AB is equal to mu A divided by mu B is equal to sin I by sin R. That that ray enters medium A from medium B. The absolute refractive indices of the two media mu A and mu B respectively. I is the angle of incidence in the medium B. R is the angle of refraction in the medium A. Therefore, mu A mu B is the refractive index of the A relative to the B. When the angle of incidence and the angle of refraction are small, we can write sin I is equal to I and sin R is equal to R. Therefore, mu A upon mu B is equal to sin I upon sin R. This result is to explain the image formation when the refraction takes place at a spherical surface. Okay. Then a point object is kept on the axis of the surface in the first medium at a distance u from the pole of the surface. Rays starting from the object get refracted at the refractive surface and a point image is obtained in the second medium at a distance v from the pole of the surface. Then we get mu2 upon v minus mu1 upon u is equal to, that is mu2 minus mu1 divided by r. This result can be used for both the convex and the concave surface, both when mu2 greater than mu1 or when mu1 greater than mu2, both for the real and the virtual objects and the images, provided the following conventions are used in making the measurement. Distance are always measured from pole of the surface and along the axis of the surface. The distance measured along the direction of the incident rays are taken as positive. The distance measured along the direction opposite to that of the incident rays are taken as negative. Thus, according to this conversation of the measurement, the radius of the curvature of a convex surface is positive, that are the concave surface is negative. Uh, as per the convention of measurements that may come for the MCQs, the radius of curvature of convex surface is positive, whereas the radius of curvature of the concave surface is the negative. The distance of the real object is negative, that of the virtual object is positive. That is again come for the MCQ. The distance of the real image is positive and that of the virtual image is negative. That again come for the MCQs. Then what is a thin lens? A transparent medium enclosed by the two spherical surface is called as a lens. What is lens? That may come for the MCQs. A transparent medium enclosed by the two spherical surface is called as a lens. When in a lens, the distance between the poles of the two surfaces is very small compared to the radii of the curvature of the surface, then it is called as the thin lens. What is a thin lens? That definition is given. Then what is the lens maker formula? The expression giving the relation between the focal length of the lens and the refractive index of the material of the lens and the two radii of curvature is called as the lens maker formula. Focal length is related to the object distance and the image distance, both measured from the optic center of this particular lens. Okay. Focal length, that you should know, the distance of the focus from the optic center is called as the focal length of the lens. Each lens has the two foci. If the one is, it is called as focal length, and if it is two, it is called as a foci. Then what are the conventions? By the convention, all the distance are measured from the optic center of the thin lens and along the axis, and distance measured along the direction of the incident ray are taken as positive, whereas the distance measured in direction opposite to that of the incident rays are taken as the negative. Thus the focal length of this convex or converging lens, convex lens is also called as a converging lens, whereas the concave lens is called as a diverging lens. Okay, that may come for the MCQ. Convex lens will be real and positive. The focal length of this particular concave lens or the diverging lens will be virtual and negative. That may come for the MCQ. The expression giving the relation between the focal length, refractive index of the material of the lens and the two radii of curvature is called as the lens maker formula. That is 1 upon f is equal to, and in bracket mu minus 1 in bracket 1 upon r1 minus 1 upon r2 is equal to 1 upon v minus 1 upon u. Here mu is the refractive index of the materials of the lens, r1 r2 are the radii of the curvature of the first and the second spherical surface, v is the distance of the image, mu is the distance of the object, and the lens is surrounded by the air or a cave. If the lens is surrounded by the medium of the refractive index mu 0, then the focal length of the lens will be 1 upon f is equal to mu upon mu 0 minus 1 in bracket 1 upon r1 minus 1 upon r2 is equal to 1 upon v minus 1 upon u. Power of lens. The power of lens is equal to reciprocal of the focal length measured in meter. P is equal to 1 upon f. The unit of the power of lens is dioptry. That may come for the MCQ. Okay. Thin lens is contact. Thick lens, distance between the poles of is not small. Such a lens is called as a thick lens. What is a thin lens that we have seen? When they have the very small distance in between the two poles, between the poles of the two surfaces, and which is as small as compared to the radii of curvature of the surfaces is called as a thin lens. Whereas for the thick lens, the distance between the poles which are not small is called as a thick lens. It has two spherical surfaces of radii of curvature and two distance between the two poles is its thickness. The line joining the two poles and that continue to on both sides in the axis of the lens. Then here that particular lens is considered. Then you can see this equation. We are not going in detail of such a thing. Here you will get the lens maker formula derivation 1 upon f in bracket is equal to mu minus 1 in bracket 1 upon r1 minus 1 upon r2. And a Gauss formula is there 1 upon v minus 1 upon u is equal to 1 upon f. This formula is called as the Gauss formula that may come for the MCQ. Now Newton's lens equation x1 upon f1 is equal to f2 upon x2, or x1 x2 is equal to f1 f2. X1 is the object distance from the first focus f1, x2 is the image distance from the second focus f2, and this is known as the Newton's lens equation. When the medium is same on the both sides of the lens, the equation becomes x1 x2 is equal to f square, since f1 f2 is equal to f. Then what is the magnification? Lenses are used to form a magnified image of an object. Magnification is defined as the ratio of the size of the image to the size of an object. This again come for the MCQs. Magnification is equal to size of the image divided by size of the object, I upon O. Here you can see the lateral magnification, or say transverse magnification. It is defined as the ratio of the length of an image to the length of the object. Both the lengths measure perpendicular to the principal axis of the lens. Then longitudinal magnification and angular magnification. These things may be there in the MCQ form. Then what is the longitudinal? It is defined as the ratio of infinitesimal axial length in the region of the image to the corresponding length in the region of the object. Okay, it is called as the longitudinal magnification. It is the square of linear magnification with negative sign. Angular magnification is defined as the ratio of slope of an emergent ray and to the conjugate incident ray with the principal axis of the lens. Let here the theta 1 and theta 2 be the angles made by the incident ray and the conjugate emergent ray with the principal axis respectively.